One of the most eagerly anticipated astronomical events is the supernova of Betelgeuse. In the constellation of Orion, the red supergiant star Betelgeuse is nearing the end of its life. The star will soon burst, and for several weeks, even during the day, our skies will be illuminated by the event's aftermath. Nobody is exactly sure when the star would go supernova though. Betelgeuse might have already imploded, but as it is 650 light years away, we haven't yet seen the results of that event. Before we dive into the specifics of this astronomical phenomena, hello there, and welcome back to the Discover Space channel, where we explore the universe in all its astounding glory. Be sure to subscribe if you haven't already, and let's get on to the video. Even though the great dimming of the star began in December 2019, researchers saw strange activity on Betelgeuse at the start of the year. Betelgeuse looked to be fairly symmetrical in the optical photographs of the star captured by the ESO's Very Large Telescope. However, the photospheric layers revealed evidence of a massive shock in our field of view. Light is emitted from the star's photosphere, which is its outer layer. The photosphere has begun to enlarge, the researchers also observed. The star appeared to be inflating up when viewed from Earth. For the majority of the year, Betelgeuse was expanding at a consistent rate until mid-November 2019, when the outward motion started to slow down. With this velocity, researchers predict that the ejected material will reach a height of 10 to 20% of the star's radius, well above the surface in 6 months. By mid-November 2019, the outflow has ceased, and researchers had once again captured optical photos of the star. The discovery of 2 irregularities on Betelgeuse astonished them. The first thing that the photographs showed was that the star now had a dark southern hemisphere, in stark contrast to the prior image taken on the start of the year. Second, the star's surface temperature significantly dropped. The temperature has decreased by roughly 300 degrees Fahrenheit, about a year after the outflow even started. Between January 27 and February 13 of 2020, Betelgeuse's brightness fell to a record low. The star soon began to brighten once more, and after a few months, it returned to its normal magnitude. What actually happened to Betelgeuse then? This pattern of variation in atmospheric response, the researchers write in their paper, suggests that an ejection event emerged from the photosphere, traveled out through the extended atmosphere, and ultimately produced molecules and dust as cooler regions of the extended atmosphere were reached. A disrupted local environment that was cooler and denser remained. When a material is abruptly removed from the photosphere, allowing the remaining plasma to really expand and cool, this would be expected. Therefore, all available data points to Betelgeuse's having undergone a huge, previously unseen surface mass ejection, or SME. A comparable event occurs on the Sun as well, and it is known as a coronal mass ejection, or CME. An abrupt ejection of material, typically from the solar corona to the heliosphere, causes solar coronal mass ejections. Additionally, the phenomena seen on Betelgeuse can be explained by this solar mechanism. The Betelgeuse ejection, however, was much smaller than what occurs on the Sun. This is due to the fact that the 2 stars differ in size and stage of evolution. Betelgeuse differs from the Sun in that it has a lower gravity, a radius that is 1,000 times that of the Sun, and no solar corona-like high temperatures. 400 billion times more mass than a normal explosion on another star, or a typical CME, was ejected by Betelgeuse. This is being pushed out at an amazing speeds, and is many times the mass of the Moon. According to the researchers, They have never before observed a massive star surface mass ejection. They can use Hubble to directly see and determine space characteristics of this novel occurrence. As a result, we are witnessing in real time a stellar evolution, the aging of a collapsing star. The inexplicable dimming was caused by a dusty shroud obscuring the star, which was triggered by a decrease in the temperature on Betelgeuse's luminous surface. Researchers don't know what triggered the SME or when a similar occurrence might occur again, but the star has been severely impacted by this circumstance. The star first shed a sizable amount of mass all at once. A dying star can lose a lot more mass than it normally would due to a stellar wind, according to an SME of this size. Betelgeuse appears to have blown off and is now gradually recovering. Additionally, for a long time after Betelgeuse blasted off a significant piece of its surface, the stardust obscured it from our telescopes. It had lost some of its brightness as a result of the huge mass ejection, but not as much as astronomers had predicted in prior calculations. In a nutshell, this ejection not only caused the great dimming, but also the drop in the temperature of the Betelgeuse. It is difficult to determine when it will go supernova. Researchers estimate that it will have at least 100,000 years more to live. So there is a good chance that we won't witness it explode in a magnificent supernova during our lifetimes. For the time being, scientists intend to use the James Webb Space Telescope to conduct thorough infrared investigations of Betelgeuse. To find signs of this mass loss event, they want to observe the circumstellar zone to the south of the star. In the 4 years that have passed since the outburst began, the debris must have traveled a long way. Deeper understanding of the physics and development of post-main sequence stars will be possible thanks to James Webb Space Telescope's studies of Betelgeuse. Betelgeuse's spectacular appearance in the evening sky will undoubtedly keep us interested as we continue to observe its behavior and look for any signs of what the future may hold for it, at least for the moment. And when Betelgeuse explodes as a supernova, mankind should expect a spectacular light show. For a while, it will glow as bright as the moon. It will be so brilliant that you may even see it in daytime. And that is it for this video. Thank you so much for tuning in with us for yet another spectacular astronomical event. Be sure to comment below what other spectacular astronomical events you want to explore next, and we shall see you then.